In this video, I'll be explaining Chapter 15.5, Calculating Equilibrium Constans. So at this point, you should be familiar with the concept of equilibrium already. Equilibrium occurs when opposing reactions proceed at equal rates. That just means the rate of formation of the reactants and the rate of formation of the products are the same. So this right here is the equation of a generalized chemical reaction. And this is the equilibrium constant expression for the reaction. Kc, the equilibrium constant, equals to the product of the concentration of the products over the product of the concentrations of the reactants. And each coefficient in a balanced equation becomes an exponent in the equilibrium expression. And it's also important to know that this is only true when all A, B, C, D are in the gas phase. In other words, you only include the concentrations of the gases in the equilibrium expression, because the concentrations of the solids and liquids do not change as the reaction happens. Now that we have looked at the general equilibrium constant expression, let's look at some real chemical reactions and find their equilibrium expressions. So for the first one, we have Kc, equilibrium constant, equals to product over reactant. And what's our product in this case? It is CH3OH. And for reactants, we have CO2 and H2, hydrogen gas. And because there are 2 moles of hydrogen gas, we need to raise the concentration of H2 to the second power. And that is the expression for this one. And let's look at the other problem. Let's take a pause and work on this problem. Now that we have finished, I think many of you would have this as your answer. However, there's a difference between these two problems, and that is the phase of the reactant. In the first example, all 3 substances are in the gas phase, and that's why all their concentrations can be included in the equilibrium expression. However, in the second example, the reactant is a solid, and because the concentration of the solid does not change as the reaction happens, this should not be included in the equilibrium expression. Instead of its concentration, you would just write 1 as the denominator. But what does the value of K mean anyway? So K, the equilibrium constant, represents the relationship between the reactants and the products when the reaction reaches equilibrium. If the constant is smaller than 1, that means the reaction is reactant favored, and there will be more reactants at equilibrium. On the other side, if K is greater than 1, the reaction is product favored. That means there will be more products than reactants at equilibrium. So now you understand how the equilibrium constant expression works. Let's move on to a sample problem. So let's take a look of what is given in this problem. First, we have the volume of the container, and we also have the moles of all three substances. And with these given information, we can first calculate the concentration of each substance. The unit of concentration is molarity, m, and it equals to moles over liters. So let's first take a look at the concentration of Br2. It equals to 0.25 mole over 3.0 liters. And we get 0.083 molarity. And let's do the same for Cl2 and BrCl. Now that we know all the concentrations, we can write our equilibrium constant expression. Be careful and do not forget the exponent because there's a coefficient in the original equation. And because the equilibrium constant is greater than 1, we know that there's more products than reactants. However, not all problems are as easy as this one. Most equilibrium problems you'll see only give you initial and equilibrium concentrations. So now let's take a look at one of these problems. We still have the same information about the volume of the container, but instead of giving us all of the equilibrium concentrations, we have the initial concentrations and only one equilibrium concentration. So with this information given, we can calculate the initial concentration of all reactants and products. Now that we know all the initial concentrations, what's the next step? And this is when the ice or rice table comes in handy. So let's fill in what we know. First step is just copying down the balance equation. Then we can fill in the initial concentrations we just calculated. So these are all the information we know. What happens during the process of reaching equilibrium? The concentration of NO decreases 2x because it's coefficient. And the same thing happens to H2. And as the reactants becomes products, the concentration of the products will increase. And using these information, we can set up an equation and find out what x is. And now we can set up our equilibrium constant expression. So we use the concentration of the products divided by the concentration of the reactants. And do not forget the exponents of the concentrations. And because the equilibrium constant is greater than 1, we know that this reaction is product favored. Thank you for watching, and hopefully now you understand the topic on calculating equilibrium constant.